So you might have heard that carnivore is really bad and it's really dangerous, and there are a lot of arguments against it. And in this video, I'll be covering all of those arguments that are against carnivore and saying why carnivore is absolutely terrible for you. Now, I'm pretty sure that I have all of the arguments in this video, but if I don't, I definitely have the rest in my channel and especially my playlist, so you should go check that out. And based on all this information, you'll be able to make your own conclusions. So let's get to that first one, fiber. Now, obviously, if you're carnivore, then you don't have any fiber, and fiber is absolutely an essential nutrient because everybody needs fiber. Well, if we look at the study behind whether or not fiber is or isn't helpful for digestion, we actually see the exact opposite response. Not only do we see the exact opposite response, we see that increasing fiber intake actually increases the damage from these autoimmune problems, whether that could be basically anal bleeding, it could be constipation, it could be stomach bloating, it could be stomach cramps, doesn't matter what it is, it increases them, it doesn't decrease them. And Paul Mason has already shown this in one of his presentations. And as you can see, based on this graph, yes, you can see just how effective removing dietary fiber is at actually preventing all of these problems from happening. It's literally remove all of the fiber and you have no problems whatsoever. And if we really want to see somebody who actually lost their colon due to fiber, then we can just look at somebody by the name of Kent. Now, Kent really got screwed over, and he lost his colon because he followed the doctor's nutritional advice. That was probably not the best idea, it turns out. And that's him, so you can see him in person, as well as the 66 other patients in that study. The second argument is LDL cholesterol and saturated fat is bad for you, and that atherosclerosis will happen, and this will be caused because of high amounts of saturated fat, which is definitely bad for you. Well, we can look at this argument actually two ways. We can look at it through the lens of money, or we can look at it through the lens of what's literally happening in terms of the biochemistry. First, let's follow the money and let's see what the money says. Well, it turns out when you follow the money and you look at the studies and what's basically funded, these two studies were both funded by the exact same group. And yet one of them was released and published on time with no delays at all. And it shows that cholesterol is definitely bad for you, even though in the results, it actually has no proof for this and the results did not show this. But the other study was actually only published 45 years later, which is very strange because why would one of them be published immediately and why would one of them be published 45 years later? Well, it turns out that it's because they got completely different results to such a dramatic point that actually decreasing LDL cholesterol by 30 milligrams per deciliter actually increases all-cause mortality by 22%. Yes, and they were both funded by the exact same people, except one of them suddenly had its funding cut and completely removed because it showed contradictory results. Can you guess which one that was? That's right. It's the one that shows that LDL is actually healthy for you and LDL is good for you. And Mr. Dwight D. Eisenhower himself sadly did follow this information, and as you might already know, Mr. Dwight D. Eisenhower ended up dying from a heart attack, and it, lo and behold, was because he had, you guessed it, low cholesterol, very low cholesterol. Now, obviously, this study only being published 45 years later is a little bit suspicious because it sort of sounds like there are certain interest groups who have a lot of money at play and they want to be able to make some money. Yeah, I think we know who those are now. Now we're going to look at LDL, except we're going to look at it from a biochemistry perspective, and we're going to see what exactly LDL is and why LDL doesn't actually do anything. Now, if we look at this from a biochemistry perspective, saturated fat basically looks like this, and all it is basically just this giant chain, and there is no double bond there, as you can see. However, if we look at polyunsaturated fat, we can see that there is a double bond there, and that double bond makes a really big difference. And the reason it does is because that double bond allows for resonance stabilization, and it also allows for basically the electron to be more freely moving, which is basically what gives it that pi bond. And that pi bond is a very big deal when it comes to something called lipid peroxidation. Now, lipid peroxidation pretty much is where a free radical will attack a fat of any kind, and preferably it does choose polyunsaturated fats, and that's because they have these double bonds, and it's because that double bond once again has a pi bond, and that pi bond allows for delocalization of the electron, which means the free radical is extra happy to attack it. So once again, this statement about saturated fat being very unhealthy doesn't actually make much sense. Now let's look at that third argument. Meat causes type 2 diabetes. Now it turns out that if we look at that argument a little closer, it actually does cause type 2 diabetes, and at the same time it doesn't cause type 2 diabetes. So how does it do both of them? That doesn't seem to make much sense. We already know that type 2 diabetes is actually just chronically elevated insulin, and that's because there is very, very high insulin levels. And we already know that insulin is increased when we eat carbohydrate, and that's because carbohydrates turn into glucose. And we already know that carbohydrates are found in starchy foods, and just some examples could be like vegetables and fruits, or even processed foods. Now, we also know that type 2 diabetes is caused by this constantly high level of increased insulin. And this chronically high insulin is really the big problem when it comes to specifically, yes, you guessed it, type 2 diabetes. If we mix in some endocrinology and we understand how fat actually increases glucagon and how mixing the two actually skyrockets the insulin to glucagon ratio, making it primarily insulin dominant, meaning even higher amounts of insulin in the bloodstream, we will see that meat does cause type 2 diabetes when it's mixed with a lot of starchy foods, and meat doesn't cause type 2 diabetes when it's not mixed with starchy foods and you basically eat meat and only meat, or meat and very, very little carbohydrates. So once again, that one's not really that true. The fourth argument is vitamin C. Well, meat doesn't have vitamin C in it, and we absolutely need vitamin C because vitamin C is essential in order for us to basically have good teeth and not have scurvy. Obviously, we need vitamin C, right? Well, first off, we already know that vitamin C just acts as an antioxidant as one of its functions, and that is important, especially when you're having high amounts of oxidative stress. However, in the human body, we probably don't have very high amounts of oxidative stress in comparison to plants, and if you're interested in that, you can go check out the Rubisco enzyme video, which explains that in way more detail. And secondly, vitamin C and glucose are actually very, very similar in structure, and it turns out that when you basically try to say, hey, I want some vitamin C, and you have high levels of glucose, your body goes, well, I can't really tell the difference between vitamin C and glucose because they both compete for the same transporter. So you're actually absorbing less vitamin C by eating plants because those plants have carbohydrates. And once again, carbohydrates have the same thing, exactly, glucose that we mentioned before. So that's kind of a big deal. And not only that, there turns out there actually is vitamin C in meat, and it's a different form of vitamin C. It's called dehydroascorbic acid, and dehydroascorbic acid actually is able to compete with multiple transporters, meaning it has multiple more options for it to be absorbed in the human body, which makes a really, really big deal when it comes to you getting enough vitamin C. And once again, that makes the vitamin C argument not true. Now, the fifth argument has to do with, well, what about essential nutrients that you get from plants that you just can't get from animals? There has to be some essential nutrients, right? Now, if we just look at the protein content as one of the essential things, we already know protein content is exorbitantly higher in animal foods. However, if we also look at the vitamins part, we also see that every single vitamin except vitamin C and vitamin E are much, much higher in animal foods once again. So why exactly would we eat plant foods? Well, turns out that vitamin E isn't actually as important as you think. And the plants are producing that vitamin E because they're actually killing themselves at a very, very rapid rate. And there is vitamin E found in animal foods, although it's a little bit lower, and there's a very good reason why. And that has to do with vitamin mineral interactions. And if you're interested in that, you can go check out that video. The sixth topic is ketoacidosis. And being carnivore will obviously make your blood acidic, because we already know that if you look at a diabetic and when they're in a diabetic coma, their urine is absolutely flooded with ketones. That brings up a good point. Is ketosis and ketoacidosis the same thing? Well, turns out it actually isn't, and you can prove this a lot of ways. But just one of them, for instance, would be Mr. Angus Barberi. Now, Angus Barberi, he fasted for around 382 days, and that is absolutely insane. That means he ate absolutely nothing for 382 days, and he was primarily relying on ketones in order for his body to function. Now, turns out he didn't actually have absolutely tons and tons of ketones in his blood, causing this ketoacidosis, and for him to suddenly get ketoacidosis. No, in fact, he was perfectly fine through all of those 382 days. And you don't even have to just look at Angus Barberi. You can also, in fact, look at babies, newborn babies, because newborn babies are very, very heavy into ketosis. And if you look at their blood glucose, a regular blood glucose for a baby is somewhere around 35 milligrams per deciliter, which is 2 to 3 times lower than the average adult blood glucose. And if you saw that and you saw a 35 blood glucose, you would assume that that person, whoever it is, has passed out or maybe is even about to die. Now, this is not the case for babies because babies aren't born and they just suddenly die. They actually are running off of ketones, and primarily ketones. In fact, brains prefer, as well as hearts, prefer ketones. It sort of means that ketosis and ketoacidosis aren't necessarily the same thing. The seventh argument against carnivore is the brain's primary fuel source and the body's primary fuel source is clearly glucose. Well, we already know that this isn't true, not just from the babies that I mentioned before, but we also know that when the brain is in a fasted state, it has the choice between either using glucose or using ketones as energy. And if it needed more amounts of glucose, it would produce that through gluconeogenesis and it would feed it to the brain. But it turns out the brain doesn't do that. In fact, it actually hogs and it prefers ketones, and it uses ketones up to 66% as its primary energy source. And would you look at that, what a surprise. Turns out the rest of the body doesn't actually need glucose either, except only one cell in particular, and that is your erythrocytes. And erythrocytes also are known as red blood cells, and they are the only ones that cannot run off of ketones or fatty acid in this case, and the reason is because they absolutely need glucose because they don't have a mitochondria. The rest of your cells are perfectly fine without glucose, and they actually prefer it. The eighth argument is red meat is obviously associated with cancer in one way or another, right? I mean, clearly meat leads to cancer, and that's even what the WHO says, right? Well, we already know that cancerous cells do really love glucose and they cannot run off of ketones. But how exactly does meat even cause cancer then if you're not feeding your cells glucose much, if at all? In fact, you're feeding them ketones and fatty acid. Isn't that a little strange? How exactly are cancerous cells supposed to survive if blood glucose levels are so low? And for some reason, it seems as if lowering blood glucose actually will help get rid of the cancer. You know, that's a very good question. The ninth argument is, well, if we just look at vegetarians, obviously we see that vegetarians just live longer based on worldly data. And all we have to do is just look at the blue zones and compare the blue zones' average age. And we can clearly see that vegetarians obviously live longer. If this statement were true, let's just look at vegetarians and the place that eats the most vegetables and the least meat. We already know that is India, and India's lifespan is 67 years of age. Yes. Now we can do the exact opposite and see the place that eats the most meat, and that is Hong Kong. Hong Kong's average age is 85. Well, clearly poverty plays a role in average lifespan, right? I mean, obviously, well, yes, it does play a role in the lifespan, although can you argue that it plays a 20-year difference? I'm not too sure about that, but let's look further. Let's look at the blue zones. It turns out if you go there quite literally, or you travel a lot, like me, for instance, then you would be able to see it for yourself. And if we just look at Ikaria or Okinawa, we already know that Okinawa eats primarily Spam, and I mean so much Spam to the point where it is just a part of regular cuisine. And not only that, Ikaria, and if you look at the nutritionist who quite literally goes over there herself to see what they eat, it turns out they eat primarily meat. A lot of meat. And not only that, this whole blue zones thing is a little bit suspicious because there was quite a bit of pension fraud in this whole process, which is a little suspicious.
There's a lot of dairy on this island. Almost everyone we've met and everyone I've heard of has animals on their property for dairy, for meat, and for egg. We've interviewed several people and everyone has said they eat meat on a daily basis. These are not tourists. These are people that live here and have lived here generationally their whole life, and their parents and their grandparents, and they eat meat every day.
The 10th argument is that we evolved eating carbohydrates. Clearly, we evolved eating fruits and vegetables, obviously, and we are adapted to eating fruits and vegetables, and our ancestry does not say that we are adapted to eating meat. Well, if we actually do a little bit of a history lesson, it would turn out that we actually did evolve from primarily eating meat, but our most original ancestors did. Our least original ancestors, the gorillas, specifically Miocene hominids and Australopithecus, were the ones who were eating primarily plants and fruits, vegetables, basically grain. They were chewing most of the day. However, the early Homo sapiens were, for instance, like Homo habilis or Homo erectus, or even the middle Pleistocene Homo sapiens, for instance, Neanderthals, were highly carnivorous, and we already know this based on stable nitrogen isotope studies. And if that wasn't enough, we already know that cave paintings do exist, and that also show, turns out Homo sapiens were actually eating primarily meat and meat only. The 11th argument against carnivore is, well, obviously everybody has different genetics, right? Clearly, some people just are better off eating fruits and vegetables, and some people are better off eating meat. So this has to be a thing of genetics. Now, we can look at this in two ways. One, try to show one species from the animal kingdom which eat completely different things, for instance, one eating only meat and one eating only plants, and show me how they do. Well, it turns out that doesn't exist in the animal kingdom. Or we can look at it through the second way, which is actually just looking at the digestive tract as well as our ancestors. So let's look at our digestive tract in this case. We already know our stomach pH is around that of a carnivore, basically 1.5 to 2, if not even lower. Our small intestines seem to be about the same size than that of a carnivorous animal. Our cecum is residual and does not exist, meaning we cannot derive any sort of value from fiber at all, because once again, fiber turns into short chain fatty acids for anybody who has a cecum or any animal who has a cecum, including cows. And our large intestine is the same size as a carnivorous animal. Strange how everything seems to be leaning towards carnivory when it comes to human anatomy and understanding the digestive system. You know, isn't that strange? Maybe they'd be doing better eating meat. The 12th argument is linoleic acid, and linoleic acid is absolutely healthy and essential for you, and you need to consume linoleic acid because you cannot make it on your own. And we already know that plants have very, very high amounts of linoleic acid. And yes, plants do have high amounts of linoleic acid, but they don't have high amounts of conjugated linoleic acid. And there's a big difference because conjugated linoleic acid doesn't actually have that same arachidonic acid being incredibly inflammatory for it. In fact, it has the exact opposite effect and it's not as inflammatory. However, if we look at linoleic acid, we already know that linoleic acid converts directly into arachidonic acid, and arachidonic acid is heavily, and when I say heavily, I really do mean heavily inflammatory. And in order to prevent this heavily inflammatory process, you need the conjugated version of it. And where do you get that conjugated version from? Exactly. You get it from meat. The 13th argument is carnivore will absolutely just kill your kidneys and you're gonna die. So, okay, I don't know where this information comes from in the first place, but unless you're really dehydrating yourselves on carnivore, you're not going to kill your kidneys. Seriously, I really don't know where that claim comes from, because even if we look at it from the plant version, where exactly are you gonna get those calcium oxalate stones? Yes, you guessed it. You're gonna end up getting it from oxalates, because calcium will basically bind to the oxalates. More specifically, the oxalates will bind to the calcium, because the oxalates are going to say, hey, you know what, I have a really strong affinity for metals, and it will bind to the calcium. And what do you get in the process? Well, you get glass shards in your kidneys. So yeah, again, I have no idea where this claim of meat causes kidney problems comes from. Doesn't make much sense to me. Maybe somebody can tell me in the comments below. Yeah. The 14th argument is your liver prefers glucose and it will definitely harm your liver. No, your liver actually doesn't prefer glucose. In fact, we already know glycolysis and gluconeogenesis are a thing. And we also know that the liver, why it doesn't prefer it, is because we know the damage it causes to all cells. Yes, and I mean glucose causes damage to all cells. And the way it does this is it has more NADH in it. And I think the ratio is about 5-1, meaning that 10 NADH are produced and 2 FADH2 are produced. And you don't want more NADH produced because it goes to complex 1, and complex 1 is much more prone to electron leakage, and that electron leakage leads to reactive oxygen species. Now, if we look at the exact second part, specifically fatty acid, we already know that beta oxidation produces around 31 NADH and it produces 15 FADH2. Now, this is a big deal because the ratio is only 2-1 and you're actually getting less NADH from oxidizing fatty acid. So just from that alone, that should tell you that you want less NADH, and the reason is because you want less electron leakage and you want less reactive oxygen species being formed. And take a guess, where do you get all that glucose from and where do you get all that NADH from? That's right, you get it from plants and you get it from fruits and vegetables. And where do you get all that FADH2 that you want from, because you're getting less NADH? That's right, you get it from meat. So once again, your liver does not actually prefer glucose. It much more prefers the other side of the equation. hopefully that explains it. Now, the 15th argument is that we are just like omnivores, obviously, like bears, for instance, and we're able to eat everything. Now, theoretically, actually, yes, I do agree with this argument, and the reason is because we can eat anything. Just because we can eat everything, though, doesn't mean that we should, and it more specifically does not mean that it is optimal. In fact, it is definitely not optimal to eat whatever we want. And basically, when it comes down to it, it's all whether or not you want optimal health or you don't want optimal health, because that short-term gratification does feel nice in the time, but once again, it does come at a price. So it's all up to whether or not you or you don't want optimal health. And yes, that short-term gratification at the time of taste really can make you feel good, but once again, it does come with consequences. Well, hopefully, based on this video, you could see that all of the arguments against carnivore given actually don't hold up at all, in fact. And it seems like there's a lot of money that must be backing all of this stuff saying that carnivore or meat is very, very bad for you. Now, if you're really interested in that video, I recommend you check out my video called "The Rich Don't Want You to Eat Meat." Yes, and there's a very, very good reason why. It's messed up, but regardless, if you're really interested in that video, go check that out. Now, if you found this video informative, then please share, subscribe, like, and comment down below, because it really does help the video grow, and it's how you can show your appreciation for the video. And please share this with other people so they can see the arguments against carnivore and why they actually don't really exist at all. They don't hold up in any way at all, especially when looking at it from a biochemistry perspective. And if you want to see content ahead of time as well as help this channel grow at the same time, then please click the join button down below where you can do exactly that. So once again, thanks for watching. I'll see you in the next one. Peace.